everyone! Today we're going to be starting linear functions and lines, and we're going to be focusing on angles and divisions in this lesson. There are a few formulas for you to memorize in here, so make sure you watch carefully and see how I use them. So, I'm going to start off by introducing to you angle between lines. Okay, so basically what this means is when we have two different lines, this line and this line, so two different linear lines, okay, the first one has y equals to m1 x plus c, and the second one has equation of y equals to m2 x plus d. So if these two are two linear equations, we want to find the angle between those lines. So can you see that theta there? That's what we're aiming to find in this section. Okay, so this angle is what we call the angle between the lines. Okay, so the acute angle theta between two straight lines, which I just mentioned that theta, is given by this particular formula. Tan theta equals to absolute value of m1 minus m2 over 1 plus m1 times m2. Okay, and you should know that m1 and m2 are the gradients of these two lines. Okay, so m1 is the gradient of this line and m2 is the gradient of the second line. And yes, you do have to memorize this one. This is a formula that you must memorize, and you must use this one whenever you're asked to find an angle between those two lines. Okay, and of course when you're looking for theta, you probably have to inverse tan. Okay, that will be your next step to find theta. Okay, so shift tan and do that to find the inverse of tan to find that particular angle. Okay, so that's basically it, guys. Put that formula down somewhere. Try to familiarize yourself with this one, and let's try use this one in our questions. So starting with question 1, it says find the acute angle between the lines y equals to x minus 2 and y equals to 2x plus 3. So these are two lines given to us, and what are they asking us to find? The acute angle between those two lines, and make sure it's the acute angle. So I just drew a picture or a diagram or a sketch to show you what these two lines look like. Okay, you don't have to draw a diagram every time you do these questions, but I just want to show you what an idea of what this looks like. So the first one, y equals to x minus 2, is given by this line, and y equals to 2x plus 3 is given by the other line over here. And the acute angle between those two lines must be that angle there, theta. Okay, so let's go ahead, use our formula to find theta. So first of all, let's identify our gradients. M1, okay, I'll let that be the first gradient of the first line, which is the coefficient of x, right? Y equals to mx plus b from our year 9 coordinate geometry. So the coefficient of x, which is 1, is the gradient of the first line. Now, the second line, the coefficient of x is 2, so therefore the gradient of the second line must be 2. Okay? And just watch out, it must be 1y equals to something. Okay, I hope you guys already know that. Okay, so we've found the gradients. Let's pop it into our formula. So tan theta equals to m1 minus m2, so 1 minus 2 over 1 plus m1 times m2. Okay, so 1 times 2. And make sure you put those absolute bars around them. Okay, alright, so I've got that. Just simplify it, guys. Simplify inside your absolute bars. You should get 1 over 3. Okay, you should get 1 over 3. So tan theta equals to 1 over 3. How do we find that angle theta? Simply do the inverse of tan. So theta is tan inverse 1 on 3, which simply becomes 18 degrees and 26 minutes. Okay, so that's as easy it is. Alright, all you have to do is memorize that formula, just plot your gradients in there. Okay, and just make sure that is an acute angle. Okay, so that's basically it. That's question 1. Let's go on to the next question. Okay, question 2 also asks us to find the acute angle between the lines. This time the lines are 4x plus 2y plus 1 equals to 0, and the second line is 3x plus y plus 4 equals to 0. Okay, so I'm just going to draw those lines on our axes just to show you what an idea of what it looks like. Okay, so this is the first line, this one, and the one beneath it, this one, is the second line. Okay, and as you can see, they make an angle here where they intersect, so that angle between those two lines We're going to call it theta, and that's what we're going to find. So before we do anything, we must find our gradients to insert those into our formula, right? So I'm going to go ahead and find my gradients. So with the first line, 4x plus 2y plus 1 equals to 0. See how it's not in that y equals to mx plus b form? So we can't find the gradient straight away. So what I'll do, I'll just simply make y the subject, okay, by using a little bit of algebra. So y equals to negative 2x minus a half. Okay, all I did there was make y the subject. And hope you can see that the coefficient of x is our gradient. So see the coefficient of x is negative 2. So therefore our m1, or the gradient of the first line, is going to be negative 2. Okay, as you can see that this is negative 2. So I've got the first gradient. Now let's move on to our second line, which is 3x plus y plus 4 equals to 0. So again, it's not in that y equals to mx plus b form. So I'm going to make y the subject again. So y becomes negative 3x minus 4. Okay, again, all I did was make y the subject. Alright, so again, look at the coefficient of x, because that's going to be our gradient. The coefficient of x is negative 3. So therefore, the gradient of the second line is negative 3. Okay, m2 is negative 3. So guys, we've got m1, we've got m2. So now all we need to do is put them into our formula. So tan theta equals to m1 minus m2, so negative 2 minus negative 3. Okay, it's a good idea to use brackets so you don't get confused with the signs, over 1 plus m1 times m2. Okay, m1 is negative 2 and m2 is negative 3. Okay, again, utilize brackets. Okay, so I'm going to put them all inside my absolute bars. All I need to do now is simplify it. Okay, be careful when you're simplifying with the negatives. Alright, so the top becomes negative 2 minus minus 3, so negative 2 plus 3. And the denominator here, it should become 1 plus positive 6, because negative 2 times negative 3 makes positive 6. So you should get that it's going to be 1 over 7. Alright, I'm not going to go through all that simplifying process because that should be easy for you to handle. So I'm just going to give you my final answer. Tan theta becomes 1 over 7. Okay, can you see that one? So we need to find theta though, which is the angle we're after. So therefore theta will become tan inverse 1 on 7. Okay, just plug that into your calculator guys and you should get 8 degrees and 8 minutes to the nearest minute. Okay, so that's our answer. So that angle is very, very small, okay, because the angle as we got is quite small, right? So that's the answer to question 2. We've got the final angle. Okay, so have a look at what I've done. It's very similar to question 1. And let's jump on to the next question. Okay, question 3 says find the acute angle between the line 6x minus 2y plus 1 equals to 0 and the line joining 2, negative 1 and 3, 5. So it's a bit of a different question because we've got a line, we've got the first line, and the second line, it tells us that it's the line joining these two particular points. So if I draw them for you, the solid line here is simply the 6x minus 2y plus 1 equals to 0. And see this one over here, this point is 2, negative 1, and this point is 3, 5 is given. And the line joining it, and if we extend the line, okay, that's basically our second line, okay? And therefore the angle between those two lines is the theta, the angle that we're looking for, okay, the acute angle that we're looking for. Okay, can you see that? So that's the little diagram that you can imagine in your head if you don't necessarily draw the diagram, okay? Okay, so let's go ahead and again find our gradients first of all. So from our first equation, 6x minus 2y plus 1 equals to 0, again, it's not in that y equals to mx plus b form. So we must convert it, so y is the subject, okay? So use a bit of algebra doing that, and you should get y equals to 3x plus a half. Okay, that's what I've got. I just made y the subject, and I can find the gradient now because y is the subject, so the coefficient of x, which is 3, is our gradient, which is our gradient for the first line. m1 is going to be 3. Okay, so I've got the first gradient. Now, we need to find the gradient of the second line, but the second line is the line joining these 2 points. We've got 2 points, so we can use our gradient formula. So m2 will become y2 minus y1 over x2 minus x1. So 5 minus minus 1 over 3 minus 2. Okay, so I hope you all definitely know that formula for gradient. So I'm going to just simplify that. You should get 6. Okay, so just simplify that, and m2 will simply become 6. So I've got the gradient of the second line. We've got those two gradients. We can just sub it into our formula. So tan theta is m1 minus m2, so 3 minus 6 over 1 plus m1 times m2, so 3 times 6, 1 plus 3 times 6 on the denominator. And make sure you use those absolute bars around them. And simplify, you should get 3 over 19. Okay, make sure the answer as always turns out positive because we've got those absolute bars. So what, 3 over 19, so therefore tan theta is 3 over 19. But we need to find theta, so again, do inverse tan. So theta will become tan inverse 3 on 19. Plug that into your calculator and you should get 8 degrees and 58 minutes. And that's the final solution. That's what we're after, isn't it? So this angle between these two lines, theta, is this here, 8 degrees and 58 minutes. Okay, so I hope it's logical now. I hope you're understanding all this kind of thing now. Yeah? So that's question 3. Let's go on. Okay, question 4 says, find the acute angle between the line joining 2, 3 and 4, negative 1 and the line joining 0, 5 and 2, negative 7. So this time, they give us different points that the line joins. Okay, so like the previous question, I'm just going to plot those points. So this is the first one, 2, 3 is over here, 4, negative 1 is over here. Okay, so the line joining those 2 points is the first line that we're going to be looking at. So if I extend the line, it's going to look something like this, right? And the second line, 0, 5 is over here, and 2, negative 7 is over here. Just plot them, and again, join them because we're after the line that joining those 2 points. So if you join those 2 points and you extend the line, you can see that they intersect. So the angle between those 2 lines over here is the theta that we're going to be looking for. Okay, that's the kind of idea you should be imagining. Alright, so that's what we're going to be looking at. So let's again, first of all, find our gradients. So m1, which is the line joining 2, 3 and 4, negative 1, we're going to find the gradient of that one, which is m1. So again, use our gradient formula. So negative 1 minus 3 over 4 minus 2. That's just our gradient formula, y2 minus y1 over x2 minus x1. Okay, hope you definitely know that one. Just simplify it, guys. You should get negative 2. So our first gradient is negative 2. Alright, so I've got the first gradient. Let's go on to our second gradient. So m2 will be the gradient of the second line that's joined by these 2 points. So it's going to be, I'll do 5 minus minus 7, so we get 5 plus 7, and then 0 minus 2. So I have negative 2. Okay, again using the same gradient formula. Just simplify it, you should get negative 6. So our second gradient m2 is going to be negative 6. Okay, so I hope this is easy. So we've got the first and second gradient, we've got those 2 gradients. We can just plug them all into our formula. So tan theta will become m1 minus m2, so m1 minus m2 over 1 plus m1 times m2, so m1 is negative 2 and m2 is negative 6 as we just found previously. Again, use those absolute bars to make sure that it's positive. Simplify it, you should get 4 on 13. Okay, again guys, be careful with the negative signs. There are a lot of negative signs involved, so make sure you know here, negative negative makes a positive, and negative times a negative also makes a positive. Okay, just be careful with those signs, okay? So we've got 4 on 13, so tan theta is 4 on 13, but we need to find the angle, don't we? So we need to find theta, so simply do the same thing, tan inverse 4 on 13. Okay, so that's theta, plug it into your calculator, you should get 17 degrees and 6 minutes, and that's the angle between these 2 lines. Okay, so although it's a little bit of a different type of question, it's still very, very easy and doable. Okay, so that's question 4. Let's go on to the next one. Okay, question 5 says find the acute angle between the lines x minus y plus 7 equals to 0 and the second line is x plus y minus 3 equals to 0. So again, they give us two different lines, equations of the lines, so we're going to try to use a similar pattern again as we did in the previous questions. So I'll give you a diagram again. So the first line over here, this is the x minus y plus 7 equals to 0, and the other one here is the x plus y minus 3 equals to 0. So again, I just drew them for you so you can get an idea of what it looks like. And as you can see, this over here is going to be the theta that we're going to be looking for. Alright, that looks more acute than this one, so I just thought that would be the acute angle. So that's theta. So we're going to again look for our gradients. So see for x minus y plus 7 equals to 0, the first line. And again, it's not in that y equals to mx plus b form. So I'm going to make y the subject again, so y becomes x plus 7. Okay? And the coefficient of x, which is going to be 1, is our gradient. So m1, the gradient of the first line, is going to be simply 1. Now let's go into the second equation, x plus y minus 3 equals to 0. So we're going to make y the subject again, since it's not in that y equals to mx plus b form. So the coefficient of x is our gradient. This time it looks like it's going to be negative 1, isn't it? So m2 is negative 1. Okay, as you can see, as the coefficient of x is negative 1. So we've got m1, we've got m2, we've got those two gradients. As long as we've got those, just plug them into our formula. So tan theta is m1 minus m2, so 1 minus minus 1 over 1 plus m1 times m2. m1 is 1, m2 is negative 1. Okay, and again, put those absolute bars, don't forget that. And again, as I said, be careful with when you're simplifying those negative numbers. So the top becomes 1 plus 1, because negative makes a plus, and this one, 1 times negative 1 is negative 1, right? So just be careful with those, and simplify, you should get 2 over 0 inside the absolute bars. The denominator should result as 0, okay? Because 1 times negative 1 is negative 1, so 1 minus 1 is 0. So as you can see, the denominator becomes 0. What happens if the denominator is 0, guys? Do you guys remember? If you put it into a calculator, you're probably going to get a math error or undefined. But basically, 2 over a really small number, we don't really say that's undefined. We make that as infinity. Okay? Something over a very, very tiny number like 0, it tends to a very, very large number. So we say infinity. Okay, and you should see this one in your exact value tables. So if tan theta equals to infinity, what is theta, guys? You should all remember, you should all be able to tell me that theta is 90 degrees. Okay, remember tan 90 is infinity. Okay, remember it's asymptote at 90, so therefore our final answer is 90 degrees. Okay, so the angle between these two lines is 90 degrees. So since that's 90 degrees, the vertically opposite angle must be 90 degrees, and the other two also should be 90 degrees, because that in total makes 360. Right? So that's the answer for this one. Remember this particular one, okay, might come out in your exams. So that's basically, that was the angle between the line formula. Make sure you remember that one.